Hello, everyone. I'm Mark Grand. I am a platform architect with Softvision. I've been with the company for, it'll be going on 2 years in February. I am here today to talk to you about some practices that go into creating cloud-native applications. It's based on a list of attributes that such things tend to have. This list of 15 became popular in around 2015, 2016 it came out. But there's a more famous list of 12 apps, rather 12 attributes that came out about 10 years ago, and it's more famous. So I decided to use that for the name of the presentation. So what am I here to talk about more exactly? Well, I want to discuss some good practices that will allow you to achieve reproducible results with cloud native applications at scale and with agility. So it's a lot of words, but a lot of the practices I'm going to talk about you may be familiar with, and you may learn about some practices you're not familiar with. The point is not to go in depth with any of this, but to tell you why it is that we do these things. If you understand why we do the things that we do, you'll be able to make better decisions about how you use the processes that you work with on a day-to-day basis. So hopefully you'll be getting that benefit from this. There's one definition I want to give you before I go on, which is what's a cloud native application? So a cloud native application is designed and implemented to run on platform as service and embrace horizontal elastic scaling. So that's sort of what it is, and what those things mean are things that we will get into as we go through the list of 12-factor applications. If you want to read the original 12-factor list, there's a website called 12factor.net. And this is a list of 15. The 1 through 12 were on the original list. The other 13 through 15 got added later. And they came from a book called Beyond the 12-Factor App. So let's get started with the first one, which is something that I hope we're all familiar with. So when we develop an app, we use one code base to produce many releases over time. And so why do we do this? Well, we want all of our revisions to be tracked and immutable. It's important that we know what it is that we released, so that if we need to fix a bug, we know exactly what it is we're working with. So simply using Git helps us to meet this need. Now, we also, as I said, we need to be able to track a release to a specific revision in Git. And Git gives us a few tools for that. We have release numbers, tags, or commit hashes that we can use to tie the release to its source. And then we want to arrange our code bases in such a way that we don't want to require the release of one app before another. When we do that, aside from giving us another way to fail by releasing out of sequence, it also means that our release takes more work, because if something has to be released before something else, and it's only the something else that we really wanted to do a release of, well, we have to do things in a certain order. And if the first thing is not ready when the second thing is, well, then the second thing has to wait. We'd like to be able to avoid waiting. So for that reason, any shared code for apps, such as libraries or such, should be in its own repository. That way, we can release that when we need to, and then the dependencies can pick up the updates when it is a convenient time for them. So getting back to our list, the second thing is dependency management. We want to assemble all of an app's dependencies in one place so that we can do our build. And we want to ensure that there's a consistent versioning policy followed in selecting each artifact. We don't want to be surprised and have two builds go and pick up different versions of dependencies or libraries, even if we didn't change anything. So surprises are to be avoided. And the other thing is that we want to take all these dependencies and produce a single deployment artifact. So to do this, we'll use an appropriate built-in dependency tool. And for Java, that might be Maven or Gradle. Other environments have their own tools, such as Bundler, GoDeps, NuGet, a lot of different tools. Anyhow, that's the reason for using those. And always, when you have dependencies, specify a exact version that you need so that you aren't just using the latest, which can change without warning. So externalize configuration reusably. So there are a number of things that should be managed outside of your build artifact. So code, runtime, credentials, these things need to be modified independently of each other. So the configuration you would normally keep someplace outside of your build artifact, or at least any environment-specific configuration. So as you deploy the same artifact into different environments, it's still the same artifact, and it's the environment that tells it what is different about the environment. Credentials need to be managed separately because those need to be updated independently of releases. You may need to update credentials without wanting to do another release. And as I touched on, we want to have the same deployment artifacts in all environments. When we deploy something into dev and it works, we should deploy the same thing into QA. And if that works, the same thing into a stage or production environment, then there will hopefully be no surprises because we tested the same thing that we ultimately deployed into production. A usual way to do this with container-based releases, such as Docker, is with environment variables. We will have something in the deployment mechanism set environment variables to whatever values are appropriate for the environment. For VMs, typically, solution is to copy files into the VM before launching it. And the config files will, again, contain whatever the environment-specific information is. So, and then the configuration information itself should be versioned. So you'll typically have your configuration information managed on Git. Spring Cloud Configuration Service actually gives you a direct way of pulling from that, but there are other tools that do the same. Point being that if there's a problem with the configuration, just like anything else, you want to know what version you have and be able to go back to a previous one. Bagging services as attached resources. So cloud-native apps are often microservices, but whether they are microservices or not, they should not be stateful. They should be stateless. So if they need to have some kind of state information associated with them, then that should be done through some kind of external attached resource. So we have an app here, and it may rely on some external OAuth 2 service to authenticate requests. It may use some cloud storage to access some information about some other things, or a database or perhaps Redis cache, but all these stateful things are external to the app. Now, as soon as you have external backing services, they can fail independently of the app. And so we want to build the app in a way so that it can best tolerate failures. So one way of dealing with that is a pattern called circuit breaker, where we are looking to see if a particular type of access or operation with an external resource is failing frequently. And if it is, rather than keep trying and failing, we'll decide that we're going to give it a rest for perhaps a minute or two and just assume that operations against that external resource will fail, and instead just fall back to whatever other behavior or fallback behavior that we can do instead of that. Perhaps a feature is disabled, perhaps some information is missing from a response, something along those lines. But the idea is that while that's happening, we would hope that some site reliable engineering process is active to fix the underlying problem, or perhaps rebind the app to a different resource that has not failed. Moving back, design, build, release, and run are distinct. So these should be separate phases and activities. So we want to know that your members of your team are going to be in sync about what needs to be done and how in each iteration. And so for that reason, it's often helpful if there are some clearly defined design activities that happen in every iteration. Sometimes you'll do design activities that are intended to tell you how you're going to do a build or development activity in the following iteration. So builds need to be reproducible, and they need to be reproducible by everyone. So something that helps with that a lot is to standardize on your source control management and use continuous integration tools. So Git and Jenkins are the typical tools that are used in a lot of things, but there are certainly many other tools available that do a good job too. So we want to be able to deploy the same set of artifacts in all environments to know what was deployed. And so having a naming convention for build artifacts that ties each artifact to a unique build number can be helpful. It may be as simple as having a tag that gets assigned to the commits. Whatever it is, it should be simple and something that everybody can understand. And so you want the same artifact to be able to run in different environments. And so one way to simply do that is to place the artifact in a container, like a Docker container, and inject environment variables during deployment. Stateless processes. We want it to be possible for a request to go to any instance of a service, typically because we are going to allow services to scale. There'll be multiple instances of a service. And so by keeping them stateless, we can be sure that it doesn't make any difference which instance of the service a request gets routed to. And so that means that requests can be routed to a particular instance of a service simply because it has more spare cycles than other ones. It's less utilized. Or if one fails, then you don't want to go and direct requests to that. And so it should be quite transparent to your users that you get directed to whatever instance you get directed to, shouldn't matter. So state is sometimes needed for something like session management or data caching. So again, backing services such as Redis or a Hazelcast can be used to maintain state that is shared by all the instances of your app. And when possible, try pushing the state information back onto the client so that it's not the service's problem at all. So another principle here is access services through a port binding. So the idea here is you want to release services independently of when their clients are released. So how are you going to manage that? You like everything to get released independently of everything else so that your release process can be simple, and you only need to test what it is that you're releasing and not a lot of other stuff that is going to be affected by it, because nothing will be affected by it. So to keep these things independent of each other, you want clients to access services through some kind of a port binding network connection. What you don't want to do is have services made through a library that gets combined into the same build artifact, because if it's a library, then to get the latest version, all the clients need to be redeployed. But when you do deploy something through a network connection, you may not want your clients to depend on a specific port number assignments. So one way to avoid that is with a DNS record. So you can have your service with whatever name it has, and you can provide a DNS CNAME record that includes not only the actual name to find the service at, but also what port number to use. And so you don't want the port number changes to affect the services either. And there's some platform as a service that have the ability to manage those for you. So for example, Kubernetes is quite capable of managing port numbers so that you come in on one port number, but the request is actually routed to a different port number when it finally gets into the pod instance that is going to handle the request. Horizontal scaling. So the idea here is that the load on a service is going to vary. It might peak up, it might not be used a lot for a time, and so you'd like to add or remove instances of this as needed. And so there are mechanisms that are available to automatically manage this for us as part of the cloud platforms that we use. Similar mechanism also allows us to be highly available. For that reason, we don't want to have large multi-CPU VMs that can individually handle a lot of capacity, because we would like a failure to just take out just a little bit of our capacity. So if we have, say, 6 instances and we lose one, well, we still have 5 out of our 6 instances left, and that's not a big hit. If we have one big instance that's 6 times as large as those, if something happens to it, we've lost 100% of our capacity. So high availability can be had by simply doing this horizontal scaling thing. So fast startup and graceful shutdown. If we're going to do horizontal scaling, when we decide that we need to have another instance running, then we want it now, not a few seconds from now. And so we want the new instance to start up quickly. We don't want it to have to take a long time to load a lot of things, to make a lot of connections, to do things that will take an unfortunate amount of time. So it's important that all of our app services start up quickly. Similarly, it's good for it to be able to shut down quickly, but in a graceful way so that any external resources are released cleanly. That way, when we don't need an instance anymore because demand is lower, it can go away. And if it goes away quickly, well, that saves money because we're built for less resource utilization. Something else that should be taken into consideration is that if an app is not going to shut down quickly, it might have some problem that is preventing it from shutting down. And so most of these mechanisms usually allow you a way of setting a maximum shutdown duration so that if it is not shut down cleanly within a certain amount of time after the shutdown is requested, there's a forced shutdown. So keep dev, QA, stage, and production similar. So we would like all these different environments to be the same. If we can avoid that, if we don't use different deployment artifacts, if we deploy different things into different environments, that's an opportunity for something to happen differently so that you have defects in one environment that aren't in the other. So deploy the same artifact to every environment. And when you get to production, you'd like to avoid surprises because there are no good surprises in production. So you want to apply the same deployment automation and metrics in all environments. You don't want to have any manual steps. Every time there's a manual step, there is an opportunity for inconsistencies. So also have identical backing services in all environments. So that means stuff like trying to make sure that your databases are consistent across environments. And for relational databases, there are tools such as Liquibase that allow you to apply the same changes in each environment so you can be confident of having consistent databases and other backing services in your different environments. And another thing about this is the time. When you have these multiple environments, you'd like to be able to have the process of deploying and to the next environment be quick, hopefully minutes or certainly not more than. So that's another reason for automation. Automated testing is important for this reason. It allows you to get the testing done quickly and consistently. You should also have artifact scans such as SonarQube, Twistlock, and so on that do a lot of the looking for things that are suspicious in an automatic way so that you hopefully don't have to spend extended periods of time on code reviews. So while code reviews are always needed, if you can have a tool that will point out a lot of the more common types of concerns automatically, then that saves programmer and reviewer time. Logs as event streams. So logs in a cloud environment get treated a bit differently than in a legacy data center type environment, and there are some good reasons for that. So you're going to be able, you want to make admin changes in, say, your dev environment before you try them in a higher environment, QA or production. And so to do that, you're going to want to have log events that record what happened, and you want the information about these logs to persist longer than any of the instances that you have. So service instances may come and go, but the logs that they create should stay and be there for a long time so you can figure out what happened. So for that reason, you want to ship your log events not to a local file on the VM, but to an external app or service that's going to maintain your logs. And then now that you have this place where all of your log information is in one place, you'll need to be able to review log events without knowing exactly which instance or sometimes even which app they came from. You just know that something strange happened around a certain time and you'd like to start looking through logs. And so if this is all in the same place, that gives you a way of seeing what's happening with all your apps, even though the log events are coming from a different place. If they all land somewhere where you can get a consistent view, then it's not a problem. So when you do need to start doing some troubleshooting with log items, often the only thing that you know for sure about where what you're interested in is in time. You know that something happened around a certain time. You may not know which app or instance. So whatever mechanism you're using to be able to browse through your log events has to be able to filter by time range. Hopefully it does a lot more flexible filtering, but that's an absolute minimum. So all admin tasks should be reproducible. So admin changes might affect an app, and you may think of it as being a one-time only thing, but you're often going to wind up having to do that in multiple environments. And so you may need to do the same thing again. And also, if you do it manually, you may not be sure that you did the same thing each time. So for these reasons, you should write scripts to perform all administrative changes, no matter how simple or trivial, even if it's something as simple as changing the permissions on a file or something like that. It should be a script which guarantees that you can do the same thing in every environment. So API first is something else that I strongly suggest. So the idea here is that you should define the API for whatever service or app on the back end before you start implementing. So you can use a API specification language such as OpenAPI to specify it. And what that buys you is a couple things. First of all, when you're in the process of implementing, once you have this definition, it's possible for people who are building clients for this to create a mock version of the service so they can test against that while you're still implementing. So clients aren't waiting for you to finish developing a service. And so there's Service V is an example of a tool that does that for you. Another concern here is that if you do API first, well, that means that your DevOps process can be aware that the API has changed and do appropriate things in knowing what needs to be redeployed because of that. If, on the other hand, you go and just make changes to your API in the code, and then they can be discovered after deployment, taking a code first approach, then it's a surprise to the DevOps that your API has changed, and you may wind up with inconsistencies simply because the DevOps had no way of knowing your API changed. So strongly recommend an API first approach where you always update your specification first. Telemetry is basically finding out what's going on with the app while it's performing. So while the individual instances of the app may be ephemeral, they'll come and go, you'd like to have some tools to get some measurements. The cloud platforms provide some generic measurements, such as number of requests per second, error rates, and that kind of thing. Oftentimes, you'd like to supplement that by instrumenting the app so that it can produce some measurements, such as perhaps how many requests are currently pending a response. That's a metric I've found pretty useful sometimes. If that number begins to rise, that can be an early warning that there's trouble, perhaps in a backing resource or something else. And if you want to know more about how the infrastructure is supporting apps and services, then you can review logs, but there are other mechanism called distributed tracing, which allows you to capture information about requests as they propagate from perhaps an initial service to services those dependent on, to perhaps backing services and so on. And so that can be very helpful when you send a request to one service and you're not sure where the actual problem happened. You can trace it through. It also allows you to get some timestamps so that you know how much time got spent when there are multiple services involved. So distributed tracing is something else that you'll want to implement so that you know is something working properly. So next issue is authentication and authorization. So for just about every request that you send to a service, you want to answer the question, who is asking? There are few services that don't care. So you want to make sure that each potential client has some kind of unique identity. You need to authenticate them by proving that they know a secret, such as a password, or in possession of a physical object, such as a phone or a security token. So we can be using multi-factor authentication that way. But the point is that we will usually want to have some way of knowing who it is that's asking. And once we know who's asking, we may need to ask the question, is this requester allowed to ask what they're asking? And so the way that this is usually solved is by requiring requests to include a security token, such as a JOT or SAML, and it'll be issued by a trusted entity, such as an identity provider, that certifies who it is that's asking. So I've talked through these 15 issues. I hope I've gone at a reasonable pace. And so I am now ready to open for questions, if there are any questions.
Hi, Mark. We do have one question in the chat. Is there any way to externalize configuration if I have a Docker image with a compiled app in React and I have the API routes already written in the bundle? Can I achieve this without going to the server-side rendering?
Okay. I'm not sure that I understand the issue here. Part of what most of what you're talking about, React things are normally going to be on the client, web client, not the server. If you do have something that you're doing on the server, then normally you'd be having some environment variables set in the Docker environment as part of the deployment process. So if you need to set some things, hopefully you have that set up for your environment. So if there is perhaps a particular URL that you're supposed to go to for your images or something like that, that can be in the environment variable. And you can set that up as part of your Docker if you're using Docker directly. If you're using Kubernetes, Kubernetes allows you to do that explicitly. There is a tool called Flux, which allows you to automate that process. So I hope the answer to the question is in that somewhere.
Okay, I don't see any other questions coming in from the chat right now.
Okay, well, that's all that I have. So I'll stick around for any more questions that there may be. And but that's all the content that I have.
Okay, thank you, Mark.
Okay.